Hello, and welcome to the DU Quark, a student-run journal that focuses on communicating STEM topics to a broader audience. I am Anthony Valletta, and I will be sharing a video on the growing threat of antimicrobial resistance. Imagine you just got an ear infection. You have to go to the doctor and get prescribed an antibiotic. Normally, the antibiotic works and you get better. But this time, the antibiotic doesn't work. The doctor decides to try a different antibiotic, and another, and another. Before you know it, the infection becomes pan-resistant, meaning it is immune to all known antibiotics. This makes the infection much harder to treat. This issue is becoming increasingly prevalent as bacteria and other microbes become better at resisting treatment. This is called antimicrobial resistance, or AMR. Due to the decreased discovery of novel antimicrobials and increasing AMR, infections are getting harder to treat. In fact, antimicrobial resistance is projected to outpace cancer, accounting for a predicted 10 million deaths per year by 2050. Now, to understand the AMR crisis, it is important to know how it works. There are various mechanisms of resistance, including enzymes that act as molecular tools to break down or alter antimicrobials, modified cell structure, which prevents drugs from entering, and even cellular pumps that shoot the drug out faster than it can do its job. These mechanisms make pathogens immune to an antimicrobial and difficult to treat. This becomes a problem when a microbe is immune to everything we have. This can cause an infection that quickly progresses and can even be fatal. This is especially critical for immunocompromised individuals, like those living with cystic fibrosis. These individuals have excess mucus in their lungs, which can harbor bacteria, resulting in more frequent and difficult to treat infections. But the AMR crisis is not without hope. Many scientists are developing new antimicrobials and alternative therapies. I was fortunate to attend the inaugural interdisciplinary meeting on antimicrobial resistance and innovation. This conference aims to bring together scientists from different backgrounds, including biologists, chemists, clinicians, and physicists, to better understand how to treat and prevent AMR. Much of the current research is being invested in developing new antimicrobials, which has been largely accelerated due to the application of machine learning and artificial intelligence. What used to take months or even years of research and development can now take a single week. Another avenue of interest is pairing different antibiotics together to target different parts of microbes. This can include pairing an antibiotic that targets the cell wall with an antibiotic that targets the microbe's cellular machinery. These approaches are consistent with the traditional methods of antimicrobial discovery, but new types and targets of antimicrobial therapies are also being explored. One example of these new treatments is phage therapy, which uses a specialized virus instead of antimicrobial compounds. These viruses can only infect bacteria, killing the host bacteria but leaving the infected human unharmed. Now let's return to that simple ear infection. For many people, this type of infection is still easily treatable. But for a growing number, it isn't. AMR is not a distant hypothetical problem. It is a real issue that has serious consequences. But AMR is not unbeatable. Scientists around the globe are working to stay ahead of resistant microbes, developing new drugs, combination therapies, and entirely new approaches. Solving the AMR crisis will require innovation, collaboration, and awareness from researchers, physicians, and patients alike. With new research, responsible antibiotic use, and increased public awareness, we have the tools to change how AMR impacts our future. Because even the smallest problems require big solutions. Thank you for listening, Awareness starts with conversations like these. I'm Anthony Valletta with the DU Quark. Thank you.